Alright, in this video I'm going to solve three problems. I'm going to subtract these two rational expressions. Well, it says add, but I guess really this is subtract. And what else will we do? Then we will solve this system of rational equations. Y equals this, y equals that. And finally, I will solve this inequality. Alright, every time I say rational, I'm talking about fractions, something over something. Alright, so those are the three problems I'm going to solve in this video. So let's go back and do problem number 4 where we subtract. So really the first thing we should do is look and see if there's something to factor. GCF is happening right here. So what I have is x minus 6 over, now if I pull out that GCF, I'm going to have 2 and then x plus 2. So I factored that. Yeah. So now here I have 2 x over 6. Alright, I kind of want to reduce these right now, but I won't. I'll just leave it like this. So anyway, when you want to add or subtract, you really need like denominators. So for example, over here I see an x plus 2, so I'm going to need an x plus 2 over here. And anything you do in the bottom, you're going to do the same thing in the top. So now they both have an x plus 2. Now this is a 2, but this is a 6. Now if I could turn the 2 into a 6, that would be great. And it turns out I can. If I multiply this by 3, then poof, now it's a 6. Now I can do that as long as I multiply by 3 up here as well. But if I do that, I need to use parentheses because I'm going to have to distribute. Alright, so don't just put a 3 up here and have it looking like 3x minus 6. Like, that's wrong. It's 3 times the whole numerator, x minus 6. I'm going to have to distribute. In fact, now is the time to distribute. So let me just scroll down and do some distribution. So on my next level here, I'm going to have 3x minus 18 over 6 times x plus 2. Okay, I'm going to distribute here as well. So that's going to give me 2x squared plus 4x. Alright, over 6 times x plus 2. Now, I have to do an extra step because this is subtraction. I need to distribute this minus sign. So I'm going to turn this into a plus, and I'm going to distribute the minus sign like that. So now, since I have like denominators, I can combine these into one fraction. Okay, so it's going to be like this. So I've got one fraction happening. So I'm using my like denominator of 6 times x plus 2, and I'm just going to combine all these like terms. Start with the highest power. So I've got negative 2x squared. That's going to go in the front. There's no other quadratic term. There's nothing else that has x squared. Now I'm going to do the linear terms, the x terms. So 3x and negative 4x, that just makes negative 1x, or just negative x. So that's those. And then I've just got the negative 18. So that's just minus 18. So this may be the final answer. I should look and see if I can factor this, just in case something will cancel out. But for now, I'm going to go ahead and put a box around this just in case this turns out to be the final answer. Now, if I were going to try to factor this numerator, the first thing I would do is pull out a negative 1. Okay, it's very difficult to factor when the leading coefficient is negative. If I take out negative 1, that leaves 2x squared. Now all these signs are going to change. So that would be plus x plus 18. Alright, now if I were to try to factor this now, 2x squared would have to factor as 2x and x. Now 18. Let's see, 18 can either be, let's see, I'm thinking 3 times 6. Alright, so it's either going to be 3 times 6 or 2 times 9 or 1 times 18. I think that's it. So I'll try the 3 times 6 first. Inner would be 3x, okay, and outer would be 12. Okay, inner plus outer has to equal middle. That's not going to work. I couldn't put the 6 over here either because that would make a GCF, and that should never happen. So 3 and 6, no go. How about 2 and 9? Well, I can't put the 2 here, so I'd have to go 9 and 2. Like this. That's 4 and 9. That's not 1. So that doesn't work. And the other one's going to be even worse. Alright, 1 times 18. I can't put the 18 here because that would make a GCF. So it would have to be 1 and 18. That's crazy. Alright, so it's not factorable, which means this is the final answer. Okay, so that is how you subtract rational expressions. Now, let's look at how you solve a system of rational expressions. So that's where we have y equals this, y equals that. Alright, when you see that y, know that in the end we're going to have to find not only x but also y. So your first move is going to be to set these equal to each other. So if I do that, then I've got 3 over x minus 2, and you'll notice I'm spreading them out a little bit. So plus 5 over x plus 2 equals 4x squared over, and I'm going to go ahead and factor this as x plus 2 times x minus 2. Now my method of solving a rational equation with all these fractions in it is to make the denominators the same and then cancel them out. So I'm going to go for like denominators. So this first fraction needs an x plus 2 in it. So I'll put an x plus 2 in the denominator and in the numerator. So now it has both of those. This has an x plus 2, so it needs an x minus 2. Okay, in the numerator and denominator. This already has both, so I don't need to change anything. Now that my denominators are the same, I can cancel them all out. Okay, if I do that, then what I have is 3 times x plus 2. Alright, plus 5 times x minus 2 is equal to 4x squared. Alright, so this doesn't look so tough to solve. So I'm going to do the distributive property here and here. So that's going to give me 3x plus 6, and then 5x minus 10 is equal to 4x squared. Alright, let's combine some like terms. So the 3x and the 5x together make 8x. The 6 minus 10 makes negative 4. And that's equal to 4x squared. Now I could move the 4x squared over here and I would have negative 4x squared. But I really like to leave my quadratic term, the one with the x squared, positive. So I'm going to go ahead and move these two terms over to the right. So I'm going to subtract 8x from both sides, and I'm going to add 4 to both sides. Alright, so this is now gone. So what I have is 0 equals 4x squared minus 8x plus 4. Alright, maybe this is factorable. I see that there is a common factor of 4. So I'm going to start by pulling that out. So that's going to leave x squared minus 2x plus 1. Okay, now I'm going to try to factor this. X squared will be x times x. 1 would be 1 times 1. And to make negative 2, inner, I have 1x. Outer, I have 1x. To make negative 2x, both of these need to be negative. So negative and negative. Luckily, a negative times negative is positive, so it works out. So there I factored it. To get the solutions here, I need to set each of these factors equal to 0. This constant isn't going to do anything. I'm going to ignore the 4. But if I set x minus 1 equal to 0, I'm going to get x equals 1. And this is the same thing, so still x equals 1. So this is the x value of my solution. But I'm not going to put a box around this and call it a day, because I'm remembering that this was a system of equations. It has y equals. So I need more than just the x value. I need the y value to go with it. So what I have, this x value is just the first coordinate of an ordered pair. I need the y value. So to get that, I need to take one of my two original equations and put it into my calculator table feature. I think I'll do this one, 4x squared over, okay, so I'm going to come here, I'm just going to reset my calculator real quick. So second, 0, yes, so I just reset it. So anyway, I hit the table feature and I've got 4x squared over, so that's 4x squared over, and I think it was x squared minus 4. Right. So there it is. Enter. Now I'm going to go into ask mode because that's what I like to do. I'm all about ask mode. So I want to know what happens when the x value is 1. So if I'll just type in 1, and boom, the y value is negative 4/3. So there I go, negative 4 over 3. So this is the solution to the system. Okay, that just leaves the inequality. Alright, so this will be the last problem on this video. Now, to solve an inequality, eventually we're going to have a number line, and we're going to have some values on the number line, and we're going to do some test cases to see where the solutions are on the number line. But first, we need to turn this into an equation and solve it, because that'll be the first value that goes on the number line. So if I turn this into an equation, then it will look like this. So I'll have 3/4. See, I'm looking to see how much I need to space this out. So minus 1 over x minus 3, alright, equals x over x plus 4. Alright, so I'm going to solve this equation. That's going to be one of the things that I will put on my number line. So the way I solve rational equations is I make the denominators the same. So I see 4 and I see x minus 3 and I see x plus 4. Those are three different things. Don't think you can take this 4 and put an x plus in front of it to turn it into x plus 4. It doesn't work that way. You need to do only multiplication. So for example, to look like this, this 4 is going to need an x minus 3. And I'll have to put that in the top and the bottom. Okay. Now, to look like the first one, this is going to need a 4. So I'll put a 4 in the top and the bottom. Okay. Boom. Now, looking at this side, this has an x plus 4. It doesn't have a 4 or an x minus 3, so it's going to need both of those. So it's going to need a 4, and it's going to need an x minus 3. Okay, so are they all the same now? No, because now this has a 4 and an x minus 3 and an x plus 4. So that means we're going to need an x plus 4 on all of these. So I'll need an x plus 4 here. Okay, and I'm running out of space, but I'm going to need an x plus 4 here. Alright, I should have spaced it out even more. So now the denominators are the same. Once the denominators are the same, you can cross them out. Okay? By the way, notice when I did my subtraction problem a while ago, I did not cross out the denominators. Alright? That denominator is still there. I'm only crossing out the denominators when I'm dealing with an equation. Okay? Like here, I had an equal sign. I crossed out the denominators. Alright? Here, same thing. I got this equal sign. I'm crossing out the denominators. So here's what I have at this point. I've got 3 x minus 3 x plus 4. Alright, that's what I have there. And then minus 4 times 1 is just 4. So I'm going to put 4 and then x plus 4. Alright, because of that. And then equals, and then this is 4x and then x minus 3. So this is what I've got. Let's go ahead and FOIL this out, double distribute. So I'm excuse me. I'm going to keep this 3 for a moment. If I double distribute, x times x is x squared. Now inner plus outer equals middle. Inner, I have negative 3x. Alright, outer, I have 4x. Together, that makes 1x. And then negative 3 times 4 is negative 12. So that's what you get when you FOIL these out. Okay, so now I'm going to distribute, distribute, and distribute. So that's going to give me 3x squared plus 3x minus 36. See, I distributed that. Now I'm going to distribute this. Now remember, this is a negative 4, not a positive 4. So I'm going to have negative 4x, now watch this, minus 16, not positive 16. I'm going to distribute this as well, so I'm going to have 4x squared minus 12x. Alright, now let's combine any like terms we have on the same side. I only see one quadratic term, only one x squared term, so I'll keep that. Now I'm looking at the 3x and the minus 4x. So together that makes negative 1x, or just negative x. Okay, I'm looking at the negative 36 and the negative 16. Okay, together that's going to make negative 52. Alright, and then we have the rest of it. Alright, I'm just copying this down. So we have 4x squared minus 12x. Alright, now I see I have x squared and x in the same problem. So I'm going to get 0 on one side whenever that happens. So I can either subtract these two and move them over here, or I can subtract all this and move it over there. I'm actually going to subtract this and move it over here. I know that might seem funny, but the reason is I like my x squared term to stay positive. It's much easier to factor that way. So I'm going to subtract the 3 so it'll be positive. So I'm going to subtract 3x squared from both sides. Alright, line up those like terms. I'm going to add x, to cancel that out, so plus x. And then I'm going to add 52 to both sides. So all this cancels out. So I'm going to have 0 equals. And this is just going to be x squared minus 11x plus 52. It's supposed to be squared. Alright, so we either will factor this or we will use the quadratic formula. I'm looking at the 52. Okay, 52 is going to be, I'm just going to do the quadratic formula. So let's do the quadratic formula. So the quadratic formula is all about opposite of b plus or minus square root b squared minus 4ac all over 2a. This part under the radical is called the discriminant. I always do that separately. So my discriminant, b squared minus 4ac. So that's negative 11 squared. So that's 121. All right, that's my b squared. Minus 4ac. All right, a is just 1, which I don't need to write down. So I'll just go ahead and go to the c. All right, so my discriminant is whatever this is. So it's 121 minus 4 and 52. Boom. Negative 87. That negative 87 means I'm looking at imaginary numbers. Alright, which also means this would have been unfactorable. So I don't need to go any further because I was trying to solve for x, and if I put a negative 87 under the radical, that's imaginary, and that's not the type of thing you can graph on a number line like this. So basically we will stop with this, like stop. Okay, imaginary. Alright, because it's negative. That doesn't mean that this is no solution though, because if I had gotten a value here, I would have put it on the number line. But that's not the only thing that would go on the number line, because I also would put any excluded values on the number line. And here I see 2 excluded values. X cannot equal 3 because of this, and x cannot equal negative 4 because of that. So I still have these 2 excluded values to put on my number line. So that's all I've got, so that's what I'm going to do. So here's my number line. So I've got negative 4 and 3. So let's put some points right here on as a border line, the border between these zones. And we ask ourselves, will they be closed circles or will I leave them open? Well, excluded values are always open circles, so I definitely leave these open. So now I need to pick some test values to put in between. So test values, you say. So over here, I just need something less than negative 4. So for example, negative 5. Now I'm testing to see whether or not this is greater than 0. The reason why, we really need 0 on one side, so what I'm going to do is I'm going to move this entire fraction over to the left, and it's going to become negative. And in a little while I'm going to put that in my calculator. So but to be clear, the thing that I'm going to put in my calculator is Okay, so I'm gonna go with 3/4 minus 1 over x minus 3. Alright, I've just copied that down so far. Now I'm moving this over, and so that's going to be negative x over x plus 4. Now this symbol is still right where it is, so I'm going to have greater than 0. So it's this greater than 0 that I'm looking at when I write greater than 0 here. Okay, so what else? In this zone, between -4 and 3, well, 0's in there, so why not test out and see what happens at 0 and see if that's going to give us a value greater than 0. And then over here to the right, I just need something bigger than 3, so like 4. Let's see if that's bigger than 0. So like I said, I'm going to type this into my calculator and use it to easily test these three values. So I go to my table feature, clear that out. Alright, so I've got 3/4, 3 over 4, minus 1 over x minus 3, so minus 1 over x minus 3, and then minus x over x plus 4. So x over x plus 4. Enter. I like to be in ask mode for this. Okay, so I need to test out values. This is here from an old problem, but I want to test out -5, 0, and 4. So let's see, I'll just type in -5, 0, and 4. Okay, so I got -33 over 8, and I'm trying to see, is that greater than 0? No. Okay, that is a negative number. It is not greater than 0. What about at 0? I got 13 over 12. So I got 13 over 12. Is that greater than 0? Yes, it's positive. And at 4, we got -3/4. -3/4. Is that greater than 0? No. So this yes tells me that this is where the solutions are. Right, all my solutions to the inequality are going to be between -4 and 3. Okay, so let's go ahead and show that in interval notation as well. And in interval notation, this is just going to be, it's from -4 to 3. So I'll just put -4 comma 3. And then I'll use parentheses to represent the open circles. If either one of these had been closed circles, I would have done a square bracket. Okay, so that's it. This is the solution. So really, the most important part of the solution is this interval notation right here. Alright, so that is how you solve an inequality.